All right, so we're back to do 13 to 24. Remember, we're keeping in count that we need to get 14 of these right to pass the test. So, with not much further ado, these were the ones we did in the first video. I'll put a little line here. So, we can rewrite this. P is equal to 210 x to the 3/3 times x to the 1/3, right? Because when we multiply, we add the exponents, and 3/3 plus 1/3 is 4/3. And we can do the same with the y, right? We can do 6/3, right? And then y to the 1/3, right? Because 1/3 plus 6/3 is 7/3. Okay, so the 210 doesn't have anything, right? There's no fractional exponent for that one. This is x to the first power. We'll get to this one in a second. And this one, we'll put those in a radical sign soon. And then 6 divided by 3 is a whole number, y to the second. And then we both have, these are the same, so they can go under the same radical sign, right, with an index of 3, xy on the inside. X, y on the inside. Okay, so this one was choice number 2. All right, the average cost for a gallon of milk in the United States between the year of 1995 and 2018 can be found by the model of the equation. This really wild function. You know, so if you think about it, from 95, our t for this one would, for the first choice, would be 0. Right, so the price would be, all these would be zeros. This would be $2.66. Okay, for the year 13, this is 18. T is equal to 18. Now, you can put in 18 and you can figure it out. But there's a lot of places we can go wrong when we calculate those. So I'm going to take, what I did was I put them into my calculator, right? So this one is 19 years, and this one is 23 years. So I went to the calculator, and I have a different calculator this time. I hope it does better than the other one I was using earlier today. But let's try this. Let's go y equals, and I put it all in. I put this all in, right? Just the way it is. And then I went to the table. Okay. Table. And this one doesn't have what we could put them in, but we could put in, I'm going to clear this, right? We have to put in 18. And for you, you'll go to your table and you'll scroll it, right? You'll scroll it. So that's 3.751, $3.75. So that's more. And we're looking for during which time is what year did P of T reach its maximum, right? So not that year. If we put in 19, let's put in 19, right? The price is going down, right? And then if we put in 23, the price is still going down. So 18 is our biggest, our greatest maximum of the price of milk. And you can see it on the graph too. The graph was, this is a pretty fancy graph, but you see it goes up, it goes down to here, and then it goes up a little bit, and right about here is the max. It turns around and goes back down, and that was $3.70, and at 19 was $3.47, right? And then at 23, it starts going down, right? If we come over this way, right? If we go to 23, I can't really stop. That's why the table's a little better. So I'm going to close this, right? And just remember, our table were these. So the maximum is at 2013. 18 years. So that was this one here. Okay, again, another calculator question. Right on to the next one. 15, this is crazy, right? The temperature F in degrees Fahrenheit after T hours of a roast put in the oven is given by this equation. Excuse me. Right? What is the temperature of the roast when it was put into the oven? Well, when you put it in the oven, T, the time, in hours is equal to 0. So what we have to do is put in F is equal to 325 minus 185 e to the negative 0.5 times T. Right? Oh, this is 0.5 times 0. Right? We're going to put in 0 for T. All right. So that means this is 325 minus 185 e raised to the 0 power. Anything raised to the 0 power is 1. Right? So it's 325 minus 185. And it came out to be 140. All right, which was choice 4. All right, so when you see something that is either in simplest radical form or simplest a plus bi form, you have to use the quadratic formula. It's on the reference table, the last page in the book. So make sure you look there. And this is x is equal to negative b plus or minus the square root of b squared minus 4ac. All of this over 2 times 2a. Okay, so for this one, a is equal to 1, the coefficient of the x squared term. B is equal to 6, the coefficient of the linear term. And c is equal to the constant, which is 10. So if I plug all those in, I get x is equal to negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 10 all over 2 times 1. Okay, now this becomes 36 minus 40. Right, so let's clean this up a little bit. X is equal to negative 6 plus or minus the square root of negative 4 all over 2. Now, 4 is a perfect square, right? So that's 2. So this breaks down to the square root of 4 and the square root of negative 1. This is equal to 2, and this is equal to I. Right, and if you have your calculator in A plus BI mode, you could actually put it in just like that, and you get the numerator and denominator. So this is negative 6 plus or minus 2i over 2. And then we have this triangle of doom. We could divide all those by 2. And we get negative 3 plus or minus I, which was choice number 3. Okay. Which one is not an identity? Well, this one is the difference of 2 squares. It factors to that. That's fine. This one here is x minus y times x minus y. That's good. This one here, number 3, if you multiply it out, this one is good also. I showed you a shortcut. You take the first term, x squared, right? Take x times y and double it. That's xy plus 2xy. If not, you do the FOIL, right? This is really x plus y times x plus y, right? And then you square the last term, plus y squared. So that works out. And then this, it doesn't have enough terms. When you have something cubed, you're going to have x squared terms. There's no x squared terms in here. So this one is not an identity. Number 17. All right. Here we go. Another statistics problem, which kind of like, this one kind of common sense, right? 5 teens if they take 100 samples of 5 teens, so they walk around AX5 teens, and they walk somewhere else in AX5 teens, and they do this 100 times, right? And this is the mean. 73% of the students determined 75% of teams use social media at least once per day, right? But you can see there's more people here that used 0.8, right? This one is definitely closer to the mean, and the standard deviation is closer from here to here. So let's look at our variance. So the one on the right would be a better representation of the data because you asked more people, right? You asked groups of 50. So the smaller sample size of 5 teens resulted in smaller margin of error. That's not true. The smaller was a larger, resulted in a bigger margin of error and should provide a more accurate statement. That's not true. If you have a bigger error or margin, even if you don't know anything about standard deviation, that's not true. The larger sample size of 50 teens resulted in a smaller margin of error and should provide a more accurate estimate. So that's the answer. That's the one that makes sense. Okay, and then we come down to this one, which is we have a function and we want to know something about its inverse. So first, let's solve it. Remember, this could be y also, right? So to find the inverse, this is y. We're going to switch x and y. Switch x and y. Whoop. X and y. And solve for y. That's how you do every inverse. All right, so we're going to do x is equal to y cubed minus 3. Okay. To solve for y, we add 3 to both sides. We get x plus 3 is equal to y cubed. Oops, I jumped the gun here. Y cubed. Now I'm going to take the third root of both sides, right? So I have y is equal to the third root of x plus 3. Now, in the example up here, it says negative 3b. So negative 3b has to be equal to 3. So what number for b can we plug in there, right? You probably know it just by looking at it, but you divide both sides by negative 3. And you get b is equal to negative 1. Okay? All right, 20. There's a couple of things that happen here because they don't give you the values that are in the question. You have to do something to find the values that we're going to plug in here. So let's go through this. Robert is buying a car that costs $22,000. After a down payment of $4,000, he borrows the remainder from a bank. A 6-year loan at 6.24% annual interest rate. The following formula can be used to calculate his monthly payment. So let's just talk about this for a second, right? If R is the monthly payment, R is actually going to be $22,000, the cost of the car, minus. Oh, I'm sorry, that's not the monthly payment. That's the monthly payment, right? P, the loan amount. This is what we're trying to find. The loan amount is going to be $22,000 minus the $4,000, which is $18,000. So he only has to borrow $18,000, not the full $22,000. That's an 8. Okay, so we know what P is. That's the loan amount. T is monthly interest rate, right? So the monthly interest rate, we know that he has an annual rate of 0.0624. So we have to divide this by 12. And we get 0.0052. Okay? And then I, oh, I'm sorry, that's I. Whoa, I was out in the sun for too long. I, and now our time is in months, and a 6-year loan, so this is 6 times 12, which is 72. Okay, now we're going to plug all these in our calculator. Now, you can put this right in your calculator. I'm going to try to do it on the one that I have. I didn't try it before, but we'll see what happens. Right, this is 0.0052, right? So that's the loan amount times the interest over 1 minus 1 plus I, which is 0.0052, not the yearly rate. We want the monthly rate, raised to the negative t power, which is negative 72. Okay, so let's take a look at the calculator. Right, this calculator, I'm pretty sure, does a fraction, right? So I'm going to do alpha y equals alpha y equals, right? We have 1, right? So we have that. So in the numerator, I'm going to put it just the way I just wrote it, right? In parentheses, 18,000. In parentheses is 0.0052. Okay, that's the numerator. And we go down to the denominator, we have 1 minus 1 plus 0.0052 raised to the negative 72 power. Okay, we hit enter and we get $300.36, which is choice number 2. Okay, so when you have these things that are fractions, you know, it's better to put them in as an alpha y fraction than to try to group them, because inevitably we get them mixed up, right? We don't group them right. So you could try that with your calculator. All right, so let's go back to here. This turned out to be $300.36. Now, there's one thing I'm going to just give it to you. It's up to you if you decide you want to use it or not, because we already have enough. But there are things called inverse functions, right? This one is secant. I'm going to write them up here for you. Secant theta is equal to 1 over cosine theta. Okay, now cosine theta is adjacent, so COTA is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. Okay, there's another one. It's called cosecant. And that's equal to 1 over sine. So sine is opposite over hypotenuse, so this is hypotenuse over opposite. And then there's a cotangent. Cotangent theta, right? It's the opposite of tangent. It's 1 over tangent. Okay, which is tangent is opposite over adjacent, TOA. So this one's adjacent over opposite. All right, now let's look at the problem. It's given now a couple of things, right? Pi is times 180 over pi is 180 degrees. And pi over 2 then is 90 degrees. So this is between 90 and 180, if you remember the unit circle, right? It's 0 and this is 270. So it's in the second quadrant, okay? So TOA, tangent is opposite. It's this one. This is it's 4. This one is 4, and this one is -3, right? That's the opposite over adjacent. Now we have to find the hypotenuse to do the secant. Of course, we're going to do hypotenuse over adjacent, right? And this is the theta here. All right, so this is 4 squared plus -3 squared is equal to the hypotenuse squared. Right, this is 16 plus 9 h squared. If you ever heard of this, this is the world famous 3, 4, 5 right triangle. H squared, you take the square root, right? So h could be plus or minus, oh, not hypotenuse is plus or minus, right? So it's going to be, the hypotenuse is equal to 5. So this is 5. All right, so secant is the opposite of cosine, theta. So it's hypotenuse over adjacent, which is equal to 5 over -3. 5 over -3. So it's choice 1. All right. Now, here's an equation that if you look at it, you would say, oh, let me check this out. -14 is an extraneous root? No, because you would plug it in the denominator. It seems logical that 7 and -7, that, -7 would make this one 0, and 7 would make this one 0. Unfortunately, you have to actually solve it and find the roots before you can guess, right? These are saying which statement is true. So let's find the roots. Our common denominator is x plus 7, x minus 7. So that means I have to take each one of these terms and multiply it by x plus 7, x minus 7, times 7 over x plus 7. I'm not going to put the point there, x plus 7, right? Then I have plus x plus 7, x minus 7 is over x minus 7. Okay. Oh, I'm sorry. Times 4x over x minus 7 is equal to 3x plus 7 over x minus 7 times x plus 7, x minus 7. I squeezed it in there. All right, so these two cancel out, and I'm left with 7x minus 49. This one, the x minus 7's cancel out, and I'm left with plus 4x squared plus 28x is equal to this one and this one cancel out. Now you have to do a FOIL, right? So we get 3x squared plus 21x 21x, right? Plus 7x plus 49. Okay, these two. So this becomes 7x and 28x become, so I have 4 on the left side. I have 4x squared. 7x plus 28x is 35x minus 49. On this side, I could put the two middle ones together. All right. Now it's a quadratic, so to solve a quadratic, we're going to subtract all these from the other side. Minus minus 3x squared minus 28x minus 49. So we get x squared plus 7x minus 98 is equal to 0. So obviously what I did was, the first thing I thought out, 7 is one of the roots. So I divided 98 by 7 and I got 14. So that's where the 14 came from, right? This is going to be x plus, x minus. Two numbers that multiply to be negative 98 and add up to be 7 is 14 and 7. Okay, so x is equal to negative 14 and x is equal to 7, right? So x equals negative 14 is not an extraneous root because it doesn't make any of the denominator 0, right? But if I put in 7, right, it's going to make this one. And negative 7's not even, this isn't even a root, so we don't even have to worry about that. So 3, just 7 is extraneous because we put in 7 here. 7 minus 7 is 0. And we can't divide by 0. All right, so I think that was like the first one we came to where we really had to do some serious work. I guess the dividing the polynomials is the same thing. All right. Unfortunately, 23 is another one where you have to know a formula. We did one of these, right? So if you want to know a future value is equal to the principal, the first payment, right? The amount you put in times 1 plus the rate raised to the n over 1 minus let me take that back. I have two versions of it here. I'm sorry. P minus, and we did this in another. This was the form we used before. Right, P minus 1 plus r raised to the n, and in the bottom was 1 minus 1 plus r. All right, so let's look at our data, right? Michelle deposits 250, so that's our P. Yields 0.15, right? So that rate is going to be 0.0015. Right, continues to make to $250 deposits. That's the P. For the first of each of the month for 3 years. Okay. So our time's going to be, hold on 1 second. So our time's going to be 3 times 12, which is 36. All right, so we plug these in, we get the future value is going to be equal to P minus, 250 minus 250 times 1 plus 0.0015 raised to the 36th power, all over 1 minus 1 plus 0.0015. This is 1.5. Okay, so if you clean those up a little, it's 250 minus 250, 1.0015 raised to the 36th power divided by 1 minus 1.0015. So this is choice 4. All right, and the last one on the multiple choice. A study of red-tailed hawks populations given in an area shows the population can be represented by the function h of t is 50, 1.19 t, where t represents the number of years since the study began. In terms of monthly rate of growth, the population can be best approximated by the function. All right, so this one is the beginning times 1 plus the rate raised to the 12 times t, right? The rate is equal to 0.015, and if you divide that by, nope, let me take that back. The rate is this number up here, 0.19, right? It's 0.19. That's each year. That represents for a year, right? And we got to divide that by 12, right? Where'd my calculator go? Ugh. Point 0.19 divided by 12 is equal to 0.0158, right? So now we have to 1 plus 0.0158. Our new rate is going to be 1.0158. All right, so let's put this back in here now. So our h of t is going to be equal to the original amount, which is 50, times 1.0158 raised to the 12t. So the closest one to that, approximated by the function, can best be is number 1. All right, so that's 24. I hope we can get 14 right. If not, there's some part 2 questions that most of you should be able to do, and you can get it that way. I mean, the next one is a factoring completely, which you've done many times. There is also, a division, and then there's one where you, average rate of change. We should be able to get that right. I mean, so we should be in good shape. All right, so the next video will be part 2. I'll do that one tomorrow. I hope everybody stayed cool today. Have a good night. Bye.